Hi friends, in this video we will see about remaining simulation interview questions. The first question, what is setup and hold time, how to fix? First we will see setup time. Setup time is the amount of time how much the data signal is stable before the rising edge of the clock. Y means the propagation delay of the data signal is greater than the propagation delay of the clock. Okay. So, simply setup time violations are avoided by increasing the frequency of the clock. So, in interviews they may ask how to avoid or how to solve, how to fix setup time violations. So, by increasing the frequency of clock, you can say. Next, coming to the hold time. Hold time is the amount of time how much the data signal is stable after rising edge of the clock. Here setup time is before, hold time is after the rising edge of the clock. That is you have to remember. The Y means the propagation delay of data signal is less than the propagation delay of the clock signal. Okay. Next, hold violations are avoided by adding buffers and lookup latches. Lookup latches you can solve hold violations. Next, when simulation will fail because of netlist mismatch with pattern generated netlist, hence flops will give wrong data. Hence flops will give wrong data. Mismatch will simulated and expected values. So these are the netlist mismatch or pattern generated netlist mismatch. So we will get simulation will fail. Next question, what could be the possible reasons for scan chain failures during GLS gate level simulation? GLS means gate level simulation. Hold time violations between two different clocks domains. Two different clock. One clock frequency is 10 MHz, other clock is 15 MHz. So two different clock domains. Improper stitching of scan flops, that is configuration negative followed by positive flops may not be used. Okay. No proper initialization of input sequence that may fail to put scan chain into test mode. Hold time violations within clock domain between the flops because of improper CTS clock tree synthesis because of scan rule violations. So this is the reason, possible reasons scan chain failure occurs. Next, so these are the two important questions every interviews they may ask. In parallel simulation fails serial simulation pass, what is the issue? Parallel simulation fails means shadow flop in a non-scan flop, that as D input is connected to the Q output of the scan flop, that is called non-scan flop. So D input is connected to Q output of the scan flop. So then the flop is scan flop or non-scan flop. Such shadow cells are not loaded correctly in the parallel test bench, so parallel simulation will fail. Such cells do not cause DRC violations, but the tool issue the following message in ATPG mode. It indicates that shadow cells give mismatch in simulation. So while doing ATPG itself, it will shows, so it will indicate the message also. It will give the mismatch in simulation, but you have to increase the sequential depth, and we have to proceed for coverage improvement. Okay, next, coming to next question. If parallel simulation pass, serial simulation fails, what is the issue? If parallel simulation is passing and serial is failing, then there is problem with interconnection between decompressor and scan chains, or scan chains and compressor. So connections will be mismatched, connections issues. If serial test fails, first one issue is clock screw problem, clock is not coming properly. Inform to designer, suppose if it is there, you inform to designer. If all scan test fails, because of timing violations, because of library problems, DRC issues. So these are the reasons serial simulation will fail. Why to do no timing based simulation? So basically, no timing simulation, we will check the logical operations, only logical operations will check. So to check the logical operations, interconnections, we will do the no timing simulations. Zero delay or unit delay, the ATPG we use, ATPG models simulation, we have behavioral models. ATPG tool will not simulate the clock path completely. Suppose ATPG tool issues also you will check in no timing simulation. And why to do timing based simulation? Logical and delay operations will check. Logical and both, if you want to check, we need to do the timing simulation to validate STA constraints, or to check if the clock handling SDC properly or not. So to check that one, we will do the timing based simulation. What issues you saw in timing or no timing simulation? Simulation fail scenarios. What are the issues you saw in timing or no timing simulation? Simulation fail scenarios. So here first one, no timing simulation, analog mode gives X in simulation. If OCC clock is not defined due to incorrect OCC programming, PI primary input constraints are missing in full chip simulation or SDC file, this will gives. In timing simulation, to validate STA test modes constraints, we will do the timing simulation. Check the SDC if any false path, multi-cycle paths are missing. If so, add them in SDC file and make sure our patterns are correct. So these are the things we will do in timing and no timing. And what is test setup? Initializing design into DFT is called test setup. In simulation, which one will validate first? First we will validate chain patterns, very important. Chain patterns we will validate first. Next we will validate the capture patterns. A chip on silicon has always shift output 0, that is some flops Q is stuck at 0. How will you figure out, or how will you find out? Shift with zeros and use capture patterns to capture 1 and shift out. So this is the methods we will follow. Shift with zeros and capture patterns to capture 1 and shift out. So this will work out to figure out. Why simulation debug mismatch will get? So due to library file taking wrong, or library file issues, wrong database, netlist taking wrong. What are the simulation debug steps you followed? First check shift is passing. Next, if shift is passing, then check capture. If capture is not passing, then capture debug should be done properly. How we will do? Waveform, you can check if capture pulse is coming or not from OCC, as the cut point is based on clocking report. Okay. And second one, From output logs, do diagnosis and in that diagnosis report, the failing flap will be displayed. Now go to clocking report and check if the failing flap clock pulsing or not. Clock pulsing or not, that you have to check. What is the difference between ATPG library and Verilog library model? ATPG library and Verilog library model. So ATPG files describe that fault of the macros you have in your design. But Verilog file describes the functionality of the macros with or without timing. So this is the difference of ATPG library and Verilog library. What are the mismatches in the timing and no timing simulation you have faced? How to debug? So in timing, DRC violations C6, C5, C3, C5, C6, D7, W17 violations, library problems, shadow cell issues, timing violations, clock screw issues you have faced. And how to debug? So timing simulation debug. Main issue is when the setup or world violations are not fixed. So when the timing is clean, then we must not face any issues during simulation. In most of the cases, the issue will be library mismatch or DB mismatch, database mismatch. So this comes under setup or database issue. To debug this, we will have to remove the switch -SDF error and -SDF warn and run again. This will give exact file or cell type for which the issue is occurring. So this like we have to debug. And hierarchical netlist must be read from hierarchical course. Timing definition issues. So nanoseconds versus picoseconds. Coming to the no timing simulations. In no timing simulation, netlist variation from version of netlist to other due to wrapper content at ATE not present at simulation, due to some mistakes in the netlist, X source in netlist. And no timing simulation debug. If it goes into infinite loop, then the below switch should be given. Add switch hyphen compact at compilation command vlog and compile the design. Add switch hyphen defect 0 delete loop to vsim command and run the simulation. This method directly gives the loop in the log. The best way to debug the issue by dumping the waveform and tracing back to the failing flap. So this is the way to debug the timing simulation. And coming to the which clock is given for serial and parallel simulation. For loading and unloading data, test clock or slow clock we have to use. For capturing the data, system clock or functional clock we will give. What is difference between RTL and gate level simulation, and what will these two simulations tells you? RTL simulation does not involve the propagation delay of the gates into consideration while verifying the functionality. Gate level consideration the delay of the gates during verification. Gate level simulation consider the delay of the gates during verification. The gate level simulation use real time and simulation on RTL level intended only for functional checks. What could be the reason if a flap is captured X during simulation? Forget about setup and hold violations. What can be the other factors? In most of the cases, issue will be library file mismatch or database mismatch. So these comes under setup or database issues. To debug this, we will have to remove switch hyphen SDF error hyphen SDF or and run again. This will give the exact file or cell type for which the issue is occur. And next question, in your design, if you have both setup and old violations, then which one do you first prefer to resolve? Why? I prefer old violations to resolve first. I prefer old violations resolve first, because if the design has insufficient setup time, we can decrease the shift frequency to meet the timing. So old violations we will do first. Next we will take setup violations. Setup violations we can do with reducing the shift frequency. But old violations independent of frequency. That's what we will take old violations first. Old violation we will solve first. And next one. Did you get any mismatches during EDT pattern simulation? How did you debug and fix it? So it's a you can. So this is your way you can answer. But I have taken one example I am explaining here. I got few mismatches during pattern simulation. During pattern simulation, I got mismatch on few flops. I put these flops and few flops around these flops into waveform. Waveforms you have to view in Crystal Simulator. On analyzing the waveform in Crystal Simulator, I found that flops which are having violation. In the waveform, I found that after the last shift, the scan enable signal toggling from 1 to 0, the data on the D input had a logical value 0 or 1, but scan flop captured it as X up to analyzing. I found that the late toggling of scan enable is giving violation. To solve this problem, I added 2 dead cycles between last shift and capture and generated pattern once again. So this simulation went through fine. So this is how you can say your solution also. Next question, which issue you have faced during ATPG simulation? Issues can be X mismatch or 0-1 mismatch. X mismatches could be because of improper compilation of modes. 0-1 mismatch could be because of different in custom library cell. Netlist version used for pattern generation and compiled version or could be because of improper SDF file. So these are the files, custom library file, netlist, pattern and SDF files. So due to mismatch in expected and simulated values. So this is the one type of question they will ask. And what operations will be done before loading internal scan chains? So this is the one type of question. So before loading internal scan chains, the flops inside decompressor and pipeline registers must be reset. At compressor side, the data from mask shift register must be loaded into mask hold register. This is how we have to operations will happen. Have you written any test bench to simulate patterns? Yes, I use Verilog test bench generated by Tetramax for pattern simulation. Next one, in which format you will dump Verilog simulation data? Very important, WLF format or FSDB format. So this is the one diagram flow chart. In this flow chart we can understand very easily mismatches. Suppose serial chain test fails. What is the problem? What is the problem? So here the serial test fails. So this is the problem. What is the problem? Clock screw problem, serial chain test fails, maybe clock screw problem and timing violations and library problem. These are 3 issues. Okay, 3 issues. And coming to the next one, all scan test fails. All scan test fails means timing violations may be issue, library problems may be issue. Okay, so this is the one issue. And next one, parallel pattern fail, serial pass. Parallel pattern fail, serial is pass. So serial parallel pattern fails means shadow cell issue. Shadow cell there may be problem. Next one, parallel pattern fail, serial is parallel pattern is pass, parallel pattern is pass, serial is fail, serial is fail. So this is because of DRC issue, library problems, So these are the main chart. Okay, from this you can understand different scenarios, different failures, different mismatches. Okay, so thank you everyone. If you have any queries, so email to that mail ID, and you can also comment in comment box. Okay, please comment your opinions. By that we can improve our videos. Thank you. All the best for your interviews. Thank you everyone. Thank you.